Now let us focus on the next topic, which is intersection of two planes. Let's say we have two planes. Given the first plane is denoted as pi 1 and the second plane denoted as pi 2. So when these two planes are intersect, we will obtain a straight line between these two planes, where we denote this as L. The line is L. So our aim is to find the equation of this line that is intersect between the two planes. So to find the equation of the line, what we need to have is we must have the first one is the vector that is parallel to line L, and also we must have the point that lies on the line L, maybe somewhere here. So this point, okay, or it can be somewhere, anywhere that is on the line L. Okay, once we have all these two important things, then we can find the equation of the lines. Okay, how to get the vector and the point from the intersection of two planes. Okay, we have here these two planes, but where we know that for a plane we will have a normal vector that is orthogonal to plane 1. So this is denoted as normal vector 1, where this normal vector is orthogonal to pi 1. And then we have the normal vector for the plane 2, something like this. So the intersection, so we can get a new plane that is parallel to line L when we use the cross product of n1 cross n2, because we know that the cross product of two vectors is perpendicular to these two vectors of n1 and n2, where we can, in order to determine the direction of the cross product of vector, we can use the right hand rule. Okay, so for this case, the cross product will be something like this, where if you notice, this cross product of n1 and n2 is parallel to line L. So now, our vector to obtain the equation of line is satisfied. Another thing is that we have to find the point. The point must be given somewhere on this line. So once we have this point and this vector, we can get the equation of line, where the equation of a line is equals to x minus x naught over a equals to y minus y naught over b equals to z minus z naught over c, where this n1, a, b, and c can be obtained from the vector that is the cross product of n1 cross n2, and then a point x naught, y naught, and z naught that is lies on the line L. So this will be x naught, y naught, and z naught. So in order for you to understand more on this, so let us try one example. First example, find the equation of line. So what we have to do is we have to find the equation of line that pass through. So this is the circle bracket. So it is a point that is -1, 2, 3 and is parallel to the line of intersection between planes. So we have two planes here. The first plane is 3x plus 2y minus z equals to 3. And the second plane is x minus y plus 2z equals to 5. So this is plane 2. Okay, now what we have to do is we have to, okay, first I write the equation of line, where the equation of line is equals to x minus x naught over a equals to y minus y naught over b equals to z minus z naught over c. So what we need to identify is we need to have the point x naught, y naught and z naught, where this can be written as, can be obtained by taking this point, because the equation of line, it passed through this point, -1, 2 and 3. So now our main focus is to get the A, B and C. Okay, here we have another important thing, that is we have two equations of plane. So we have two planes. Let's say the planes is drawn like this. So this is the first plane and this is the second plane. So we know that for a plane, the equation of plane is given as ax plus by plus cz equals to d, where d is equals to ax naught plus by naught plus cz naught. But our main focus is just that we want to identify what is A, B and C for each plane, because A, B and C refers to the vector that is refer to the normal vector. Okay, this is referred to the normal vector. So for plane 1, we have our normal vector where our A is equals to 3, our B is equals to 2, and C is equals to -1. And same goes with our pi 2, where the normal vector for pi 2, for plane 2 is equals to, so here is 1, and then -1, and C will be 2. Okay, what can we do next? We know that this is the normal vector for the plane 1 and plane 2. So if we draw this, so we know that this is the normal vector for plane 1. Okay, and then we have a normal vector for plane 2. So the cross product of these two normal vector will get a vector that is perpendicular to n1 and n2. And this vector also is parallel to this equation of line, where this equation of line pass through a point -1, 2, 3. So what we can do next to find the vector is that we have to find the cross product of n1 and n2. So the cross product of n1 cross n2 is equals to I, j, k. So n1 is this 3, 2, -1, and our normal vector for plane 2 is 1, -1 and 2. So now we can solve this cross product. So for I, what we need to do is just find the determinant of 2, -1, -1, 2, I minus. For j, we close this one and we have 3, -1, 1, 2, j plus. And for k, we close this row, so we have 3, 2, 1, -1 times with k. Remember that for vector, for j, it must be always minus here, negative. Okay, Then we can solve this cross product. So we have 2 times 2, which is 4 minus negative 1 times 1. So this will be 3i minus 3 times 2 is 6 minus negative 1 will be minus 7j, and then minus 3 minus 2 will be minus 5k. So now we already get the cross product of n1 and n2. So the cross product of this is parallel to the equation of parallel to line L. So now we can get our equation of line. So we have equation of line, which is x minus x naught, where x naught is given negative 1, over a, where a is 3, equals to y minus y naught, which is 2, over b, which is minus 7, equals to z minus z naught, which is 3, divided by c, which is negative 5. So this is the equation of the lines. But then I still have to simplify this. So we have x plus 1 over 3. So it can be y minus 2 over negative 7, or it can be 2 minus y over 7, equals to z minus 3 over negative 5, or it can be 3 minus z over 5.